Okay, welcome back. This will be our final part to our lesson on array layout considerations. Now we're going to talk about fire classifications. And these really come from the International Building Code, and there are fire classification requirements for roofing products. Basically, roofing products are classified for their ability to resist fire. They come in class A, B, and C. Class A is the most effective. It's effective against severe fire test exposure. Class B is effective against moderate fire test exposure, and Class C is effective against light fire test exposure. Class C would be the least effective of the roofing products and their fire classification. And yet Class C is quite common on residential buildings, although of course, depending on where the building is, you may have to have Class B or in fact Class A. I live in California, and there are very many homes that are part of the wildland urban interface. So if there's a threat of a wildfire, you may have to have a Class A roofing product. And similarly, it's pretty common for commercial buildings to be required to have Class A roofing products. These Class A, B, and C roofing products are from the International Building Code fire classification for roofing products. And over the past 10 years or so, rooftop PV systems have become so prevalent. I think in about 2012, it began when they were required to have a fire classification listing in accordance with UL 2703 testing. 2703 testing is the standard for flat plate PV modules and the racking components, included like integrated grounding, mounting devices, that kind of thing. And with this UL standard and the fire classification, PV modules and the mounting hardware were tested and listed as a system. These systems were tested at different roof slopes, whether a flush mounted to the roof or tilted up, right? So like a flush mount would be like a standard residential house on a tilted slope where the modules are just coplanar, they're flush mounted to the roof. Tilt up is when there's some sort of a rack that tilts up the modules. The reason this fire classification came around was so, hey, we don't want the racking manufacturer to have to list and test their product with every single module manufacturer out there. What happened was if a module was classified as a certain type, then the rack could get tested and listed with that type of module as a system. We're going to get in module type here in a second. To repeat, this was done so the racking manufacturers could get their product tested and listed as a system with all the different module manufacturers that are out there. And so they don't have to get tested for every single module that might be put on a roof with their racking and mounting hardware. But similar to roofing products, PV systems are classified as A, B, and C, and they can be installed on Class A, B, or C roofs. Now, the PV system classification must match or exceed the existing roof classification and, of course, meet any requirements of the local AHJ or fire department. Again, if you're in a wildland urban interface where there's the high likelihood of wildfire, I gotta think you're gonna need a Class A roof along with a Class A PV system. But again, check with your local AHJ and fire departments. So let's talk a little bit more about the fire classification requirements. And on the previous slide, I mentioned that PV modules are given a type classification. Now, this was originally UL 1703 for flat plate PV modules, but it has recently changed to become UL 61730 to really be consistent with the IEC standard of the same number. And this is where they give the module a type to certify that module and the racking system for the same fire performance without testing every combination, right? We all know there's a whole lot of different module manufacturers. There's a bunch of racking manufacturers. With this module type classification, manufacturers can kind of mix and match the type. They don't have to test their product with every single manufacturer. The PV module type evaluation really depends on how the module is constructed. There are material thicknesses, like the thickness of the glass on the front, the type of frame, and also the back sheet. Very common is Tedlar, but there are some modules that have a glass back sheet. So those are glass on glass modules. But again, the module type evaluation depends on the construction parameters of the particular module. Now, the fire performance parameters of what these modules and the racking system is put to test are the spread of flame test, which is kind of shown on the left on our slide, and then the burning brand test shown on the right. Both images from our friends at Iron Ridge, who make PV module racking. So the spread of flame test, UL wants the flame not to spread over a certain distance in a certain amount of time. And that's where we get into the different classifications of the system as A, B, or C. And then the other test is the burning brand test, where you can see like a burning brand of a certain size is put on the module itself, and it has to be allowed to burn for a certain amount of time before, if it were to burn through and catch the roof surface below it on fire. And I believe, well, there's several different burning brand tests. I think they're 1 square inch, 6 square inches, and 12 square inches. And I realize this has been a quick look at the fire classifications and module types, but you really don't have to worry about it because most of the tier 1 or bankable modules are going to be type 1, 2, or 3. I think there's maybe 15 to 20 or so different module types, but the typical module types we see on building installations are type 1, 2, and 3. Okay, now we'll go through an example using information from our friends at Iron Ridge, a manufacturer of racking equipment here in the United States. So our example, we're going to look at a PV array that's flush mounted on a steep slope roof. You can see the chart that we've taken from their installation manuals. We're going to focus on the information for the steep slope roof. Again, that's a roof slope that's above a 9.5 degree slope. So what we see by looking at this chart, we can see that the PV installer can use any type 1, 2, or 3 module to retain a Class A fire rating of the PV module and the roof system. Now remember, that's for the flush-mounted PV system. We can use type 1, 2, or 3 module to retain the Class A fire rating of that PV system, right? The modules and the racking system. Now, if you had a tilted rack on a steep slope, you could have type 1 or 2 to still retain that Class A fire rating. And then there's also low slope, but basically if you use type 1, 2, or 3 module on either of the mounting types on a low slope roof, you can get Class A fire rating. Of course, with any of this, you got to follow the manufacturer's specifications and published manuals. That is part of the UL listing. The National Electrical Code makes you follow those listing instructions. So be sure to understand what your manufacturers require. And if you don't understand it, ask them to help you out, because all the racking manufacturers will help you out with this stuff. It's not like you're piecing together all this module type and, PV racking type. I would think any tier one module you're going to purchase, tier one being like highly reputable, a bankable module, it's going to be type one, two, or three, at least if for those type of modules that are going to be put on a building. Again, if you're purchasing them from a reputable distributor, if you're buying modules off of eBay or Amazon, I'm not going to guarantee anything. And if I owned my own business, I would not be buying modules off of Amazon and reselling them. A lot of this is really taken care of for you by the module manufacturers, the racking manufacturers, and the UL standards or IEC standards. We just wanted to make you aware of the roof fire classifications, PV module types, and PV system fire ratings and fire classifications. Again, use those online instructors. If you're confused or have any questions, ask your instructors for some help. And we hope to see you sometime in the near future at our wonderful lab yard in Western Colorado, or perhaps we'll see you at one of the conferences. Stay safe, everyone.